Hello, I'm Ed Ackerman, the CTO of PSI, Photonic Systems, Inc. This is a demonstration of a self-isolating reference, or SIR algorithm that I've developed to enable a sensitive receiver to recover a signal of interest in the presence of a much stronger interfering signal that's right in the same frequency band. In this demonstration, our signal of interest will be an audio signal modulating an 88.1 megahertz carrier broadcast from this antenna. Our interferer will be a strong FM signal composed of a single tone that is hopping around within a 5 kilohertz channel at 88.1 megahertz. A Python script on this laptop computer controls this Edis radio to generate that frequency hopping interferer, which will be broadcast from this antenna. For this demo, I've implemented our SIR algorithm in MATLAB, which I'll run from this laptop. The algorithm will run and will act upon the signals that are picked up by this antenna that is connected to this box, which we call our SIR box because it's running the SIR algorithm. After allowing the SIR algorithm to act upon the signal, the SIR box retransmits it from this port, where we've hooked up both a spectrum analyzer and an FM radio exactly like this one, which we had to enclose in an aluminum box to prevent it from picking up signals other than the ones on the cable leading from the output of our SIR box. So let's start our demo now by turning on just our signal of interest, but not the interferer. So that's Feliz Navidad, the signal that we're very interested in receiving for some reason. Here's what that looks like on the spectrum analyzer. We have the spectrum analyzer. Okay, the song starts over again in a sec. There we go. We have the spectrum analyzer screen centered at 88.1 megahertz with a 200 kilohertz span. Now let's quickly see what happens when we turn on our strong frequency hopping interferer. Okay, there we go. We see and hear two things. First, we notice right away that we can't hear Feliz Navidad anymore. And second, we notice on the spectrum analyzer that within the Feliz Navidad signal of interest band, there's now this strong signal hopping around in a 5 kilohertz channel right within that band. Let's change the horizontal scale now so we can see that hopping a little better. There we go. Here's a 50 kilohertz span in which the interferer hopping within a 5 kilohertz bandwidth occupies only one of the 10 segments across. So you can see this strong frequency hopping signal inside the signal of interest band is saturating our receiver's front end, eliminating its ability to sense the weaker signal, and as a result, no Feliz Navidad for us. So like so many demos, this is a before and after type of demo. And before I turn on the SIR algorithm, the presence of the strong interferer is preventing recovery of our weaker signal of interest, as I mentioned. But now I'll turn on the SIR algorithm. And when I do that, we'll see that it suppresses the frequency hopping interferer. And you might think that we could just get rid of that interferer by putting a 5 kilohertz wide notch filter in the middle of there, and we could do that, but in that case we would lose signal in that bandwidth, and our spectrum analyzer plot would show a wide notch where we had done that. Notice that isn't what's happening here. Let's actually, to emphasize that, go back to our 200 kilohertz wide span so we can see the entire bandwidth of our signal of interest, and you see there's no notch in there. So that's why we call our algorithm the self-isolating reference algorithm, to differentiate this situation from other situations in which the interferer might be generated on the same platform as our receiver and a reference copy might be available. The self-isolating reference algorithm rather accomplishes the interference suppression by isolating a reference copy of the interferer on its own and subtracting it very effectively, as you can see from the total signal received at this antenna that we're displaying on the spectrum analyzer. As I mentioned earlier, at the moment the SIR algorithm has been implemented as a MATLAB script that our SIR box is able to stream for this live demo. But ultimately, we'll have it running on either an FPGA or possibly an ASIC, and we will be able to repeat this demonstration without the need for a laptop computer to run the SIR algorithm. We hope you'll tune in for that demo as well. thank you for your attention. Please email me any questions you might have. My address is eackerman@photonicsync.com.